Hello and welcome to Lab 13B. We have been calculating the delta TF using the equation delta TF equals KF times M, where KF is the molal freezing point constant and little m is the molality. What we're going to do today is we're going to flip this around. We're going to find the molality by taking the delta TF and dividing it by KF. And once we find the molality, we're going to use the equation for molality being equal to moles over kilograms to find moles. If we know how many moles we have, we can find grams, and that's what we're going to try to do. So, since the freezing point of a solvent is depressed the more solute you put in, what we're going to do is find the new freezing point and find the molar mass of our solute. Here's how this works. In previous years, we would have obtained the data to construct this cooling curve, but we're just going to skip the middleman. So here is a cooling curve of our solution. The original freezing point of our solvent, which is lauric acid, was originally 44 degrees Celsius. That would be here. But you can tell from this curve that the freezing point is no longer 44 degrees Celsius because we've added a bunch of solute. In fact, it has lowered or depressed the freezing point to this new point here. I'll let you read the data and determine what you think the new freezing point is. But what we're going to do is use this new freezing point to determine the molality of our solution, and if we know the molality and the mass of solvent, how many moles of solute, and if we know the mass of solute that we added, we can determine how many grams per mole. So the calculations are here. We know our solvent is lauric acid, and here is the mass of our solvent, 0.016 kilograms. We know that we have added 3.2 grams of benzoic acid, and that the original freezing point of lauric acid was 44 degrees Celsius. What I'd like you to do is record what you think is the new freezing point here, and then you're going to subtract the new freezing point from the pure freezing point to obtain the delta TF. That's going to go here, and you want to make sure that this is a negative number because we have depressed the freezing point. We have lowered it. If you know the freezing point constant and the delta TF, you can flip this equation around to find molality. That's number 6. So you're simply going to take what you think is the delta TF and divide it by the KF. Remember that your delta TF is a negative number, so that when you divided it by the KF, which is also negative, you get a positive molality. If you know the molality and you know how many kilograms of your solvent, that's lauric acid here, you can find a number of moles. Moles is equal to molality times kilograms. This is the molality from number 6, and kilograms is the mass of lauric acid from right here. This will allow you to determine the number of moles of benzoic acid you have. And if we know that we added 3.2 grams of benzoic acid, how many grams per mole is benzoic acid if we know that there are 3.2 grams for this many moles? So you're going to solve for X grams here, and that is your answer to this part here. This is the molar mass of benzoic acid in grams per mole. You're going to treat this as your experimental value and compare it to the accepted value, which you can get using the formula mass. You'll need your periodic table for this. Remember that carbon has a mass of 12 grams, hydrogens are each 1 gram, and oxygens are each 16. You'll find your molar mass using the periodic table and treat that as your accepted value and determine your percent error. If you do this right, you should get a percent error of less than 1%. I got 0.82%, so if you're not getting that, something is strange. Feel free to ask me at any point. You'll have 2 days for this, okay? Best of luck.